This is the B-21 Raider, America's newest stealth bomber. It's smaller than its predecessor, more advanced, and designed to dominate the skies for the next 30 years. The Air Force calls it a game changer. The engineering is remarkable. The technology is cutting edge. But here's what they don't lead with. Each one costs around $700 million in 2016, roughly $750 to $800 million in today's terms. The program is estimated to exceed $200 billion over its lifetime. And some of the most critical capabilities? Still theoretical. This is the story of America's most expensive bet on air superiority, the engineering that makes it possible, and the questions that make it controversial. Why replace the B-2? To understand the B-21, you need to understand what it's replacing. The B-2 Spirit was developed during the Cold War as the ultimate stealth bomber. It could deliver nuclear weapons to the Soviet Union without being detected, a ghost that kept enemies afraid to attack. But the B-2 has a problem: cost. In 2022, it cost roughly $150,000 per flight hour, not per mission, per hour in the air. Early estimates suggested around 50 maintenance hours for every flight hour, though improvements have reduced that over time. And much of the maintenance requires climate-controlled hangars. The original plan was 132 B-2 bombers at $500 million each. What we got? 21 planes at $2 billion each. That's the legacy the B-21 needs to fix. Build something advanced enough to maintain air superiority, but affordable enough to actually use. The Air Force says they've learned their lessons. This time will be different. But we've heard that before. The design. The B-21. Raider takes what worked about the B-2 and refines it. From the outside, it looks like a smaller version. And in some ways, that's exactly what it is. Analysts estimate the wingspan may be around 40 meters, instead of the B-2's 52, potentially 12 meters shorter. The overall length is believed to be more compact at approximately 16 meters. But the improvements go far beyond size. Stealth technology. The B-21's stealth capabilities rely on multiple systems working together. The airframe features a radar-absorbent coating, described in reports as sponge-like, that absorbs radar waves rather than reflecting them. Every surface is optimized for minimal radar cross-section. Engineers blended the cockpit windows into the frame, eliminated seams and joints, designed continuous curves that scatter radar waves instead of bouncing them back. The result, according to reports, an extremely small radar cross-section. Enemy radar might detect something, but it won't look like a bomber. Engine design. The engines are recessed deep into the wings, hidden from view. The exhaust system uses a narrow, two-dimensional design instead of the B-2's boxy configuration. Both changes reduce thermal and radar signatures. The bomber is believed to be high subsonic, similar to the B-2, fast enough while maintaining fuel efficiency and stealth. Flight control. The B-21 uses a fly-by-wire system. Instead of mechanical controls, dozens of sensors embedded in the wings collect data about flight conditions. Computers adjust control surfaces in real time, compensating for the challenge of controlling what's essentially one giant wing. The software revolution. This is where the B-21 fundamentally differs from the B-2. The bomber runs on what engineers call open architecture software. Instead of hardware-locked systems that require physical replacement to upgrade, the B-21 can be updated with new software. Think of it like a smartphone versus a flip phone. When new capabilities are needed, you download an update rather than buying new hardware. The idea? Keep this bomber relevant for 30 years by continuously upgrading its software instead of building an entirely new plane. In theory, it's brilliant. In practice, we won't know for decades. The manufacturing challenge. Northrop Grumman is building the B-21 at Plant 42 in Palmdale, California. The construction method is unusual. Engineers are believed to prioritize the stealth outer surface early in assembly, rather than the traditional inside-out approach. Normally, planes are built starting with the internal frame, then the outer skin is added last. The B-21 appears to reverse this priority. The smooth outer surface is built first to ensure stealth integrity. Internal components are installed through access panels, then sealed. Why? Because stealth depends on a perfectly smooth exterior. Any bump or imperfection increases radar visibility. Building from the outside ensures the stealth surface remains pristine. The B-2 required workers to remove exterior panels by hand to access internal systems. The B-21 uses simple access doors that pop open. Northrop employs over 8,000 workers on the program and has committed to delivering 100 bombers. Analysts estimate production could reach roughly 7 to 10 aircraft per year once full-rate manufacturing begins. They're using digital twin technology, virtual models of the aircraft where systems can be tested before physical production. This reduces errors and allows partners to collaborate in real time. It's an impressive manufacturing operation. The question is whether it can stay on budget. The cost problem. Here's where optimism meets reality. The Air Force has committed to spending over $200 billion on the B-21 program over 30 years. Each plane carries a price tag of approximately $700 million. That's better than the B-2's $2 billion per plane. But it's still staggering. And there's reason for skepticism. The military has a poor track record of staying within budget for advanced aircraft programs. The lifetime cost of the F-35 program is projected to exceed $1.7 trillion over its 70-year lifespan. Though procurement costs are far smaller, the total sustainment is staggering. The B-2 was supposed to cost $500 million per plane. It ended up costing 4 times that. Will the B-21 be different? The Air Force insists yes. Digital twin technology reduces errors. Open architecture software eliminates costly hardware replacements. Manufacturing improvements streamline production. But critics point out that many program details remain classified. The real cost is almost certainly higher than publicly stated figures. Dr. Dan Grazier, a defense analyst at the Project on Government Oversight, has studied military acquisition for years. His assessment: every new bomber program promises affordability and delivers cost overruns. The B-21 may be better than the B-2, but that's a low bar. There's also the question of necessity. The U.S. already maintains the world's most powerful air force. Does it need 100 new stealth bombers at $700 million each? Proponents argue yes. China is advancing rapidly, and air superiority can't be taken for granted. Skeptics argue the money could be better spent on cyber capabilities, space assets, or conventional forces that see regular use rather than bombers designed for worst-case nuclear scenarios. The capabilities. So what does $700 million buy? The B-21 can carry long-range nuclear weapons and is estimated to travel over 9,000 to 12,000 kilometers without refueling. That's enough range to strike almost anywhere on Earth from U.S. bases. But the real innovation isn't the bomber itself, it's how it fits into a larger network. The Pentagon is developing something called Joint All-Domain Command and Control. The goal: connect every military sensor and platform so they share data instantly. In this vision, the B-21 becomes more than a bomber. It becomes a command node. It could fly alongside drones, sharing targeting data and acting as an airborne coordinator. It could gather intelligence in areas too dangerous for other aircraft. Future autonomous or remotely assisted operations are being explored, though that remains speculative. The open architecture software means new capabilities can be added continuously. Surveillance systems, communication jamming, cyber warfare tools. It's an ambitious vision. Whether it actually works as planned won't be known for years. The geopolitical context. The Air Force justifies the B-21 by pointing to rising tensions. China is modernizing its military and asserting territorial claims in the South China Sea. Russia has shown a willingness to use military force in Ukraine. Both nations are developing advanced air defense systems specifically designed to counter U.S. stealth aircraft. In this environment, the argument goes, the B-2 is aging and potentially vulnerable. The B-21 provides the next generation of capability to maintain U.S. air superiority. But here's the question: is a nuclear-capable stealth bomber the right response to 21st century threats? Modern conflicts increasingly involve cyber warfare, drones, economic sanctions, and information operations. B-2 bombers have been used in conflicts from Kosovo to Libya to Afghanistan, but often for missions that could be accomplished by far cheaper systems. Will the B-21 be different? Or will it become another extremely expensive capability that rarely gets used because it's too valuable to risk? The testing timeline. Several test aircraft have reportedly been built. Congress is pushing for operational testing by 2026, but test flights are just the beginning. Achieving full operational capability, where the bomber can actually perform combat missions, could take another decade. And even then, the real test won't be whether it flies or stays stealthy. It'll be whether the open architecture software actually delivers on its promise, whether maintenance costs stay low, whether the program avoids the cost spiral that consumed the B-2 and F-35. The Air Force has made bold promises about affordability and capability. Now comes the hard part: delivering on them. The B-21 Raider represents remarkable engineering, stealth technology refined over the decades, software innovation that could keep it relevant for generations, manufacturing techniques that improve on past mistakes. But it also represents a $200 billion bet that hasn't been proven. We don't know if it will stay on budget. We don't know if the software architecture will work as planned. We don't know if it's the right capability for modern conflicts. What we do know is this. The American military is committing enormous resources to this platform based on threats that may or may not materialize and capabilities that remain largely theoretical. It could be money well spent, it could be essential for national security, or it could be another case of the Pentagon solving yesterday's problems at tomorrow's prices. So here's my question for you. In an era of cyber warfare and drone swarms, does America need 100 new nuclear stealth bombers? Or should that $200 billion go somewhere else? Let me know what you think in the comments. And if you want more deep dives into mega projects, whether military, civilian, or controversial, make sure you subscribe. Thanks for watching. I'll see you in the next one.